Okay, so let's talk about finding the t-value of paired samples. So inferences for two population means using paired samples. So we're talking about this gas problem where we had the two gasoline issues. One, we threw gasoline or a car, drove a car without the additive, and the one we drove the car with the additive. We checked what happened. We're hoping that our null hypothesis is that mu 1 is going to be equal to mu 2, but our alternative hypothesis is that the additive is going to increase the mileage. So mu 1 should be greater than, because this is the additive, greater than mu 2. So this should be a higher gas mileage. So in doing this, we found the difference between the mu's, and this is found on page 478. Okay, so we found the difference between the mu's. Okay, or actually, we found the difference between the two samples, and the difference was 0.8, 1.2, 0.7, 0.7. So we found all these differences, and then we found the sum of the difference. Okay, and what I like to do is, this is not part of the, this part right here is not part of your chart. And so what I like to do is, if I know I'm going to have to deal with this formula for finding the standard deviation, right? The standard deviation deals with the sigma, or the summation of the difference squared, minus the summation of the difference quantity squared. So let's look at the difference between what's going on here. And this is again from 107. And then that will be divided by the number of numbers, or the sample size, right? And then again, all of it's divided by the sample size minus 1. And then it's all going to be square rooted. So let's see how we go about doing this. And that's just to find that standard deviation, the sample standard deviation with respect to the difference. So we look at our differences, and we have their summation. So in essence, summation of D is equal to this. Because what we did is we added up all the differences. And that's the summation of D. Over here, this is D squared. So what this equals is the summation of D squared. So we just added up all the D squares. So what we did was we squared D to get D squared, and then added all those up. And so what that allows us to do is, it allows us to plug it into this formula. So the summation of the D squared, right? The summation of the D squares, that's this guy, or 6.12, minus the summation of D, right? Which is 6.6, but we, sorry about that, which is 6.6, but we square that, and then divide it by the number of numbers, which is 10.
Yeah.
Okay? All over, reminded, this is going all over the number of samples minus 1. And so when we plug this into our formula, we do the math, and we should get after doing the calculation, 0.443. Okay. So there's some other things we need to do. The next thing we need to do, and I'm just going to do it on this side, is we need to test the t-value. Because remember, there's less than 30 in the sample size. So we can't do a z-value test on this. We need to do the t-value test. And the t-value test with this, the difference is a little different, but it's not that much. T is equal to d bar over standard deviation of the difference divided by n. So it's still pretty much the same, right? So now I have to find d bar. Well, d bar is equal to the summation of d divided by n. In other words, you add up all your d's and you divide it by the number of d's. Simple, right? So in this case, it's really easy because d bar is equal to 6.6 divided by 10, which equals 0.66. And so now I just need my standard deviation. Well, that's what this is, right? And then I just need my n. Well, my n value was 10, right? N equals 10. So I'm good. I've got everything I need. I just need to plug it into my formula. So I have t is equal to 0.66 divided by the standard deviation, which is 0.443 divided by 10. So if I divide the 10 into the 0.443, that's pretty simple. 0.66 over 0.0443. So now I just divide that into its thing, and I get... Oh, oops. My bad. This is the... Not n.
I have a pen. No, I didn't.
Sorry. This is the square root of n.
I thought you said 10.
So it's the square root of 10. So it's not this easy. It's not this easy. It's 0.443 divided by the square root of 10. And when you do put that, but still, you're plugging it in your calculator, it's still going to pop out 4.711. 4.711. And when we're looking up, remember, we wanted 5% significance. That meant we have a 0.05 equals our alpha. Is this a one-tailed test? Yeah. Remember, it's a greater than. So we're looking at the positive, right? The positive. So when we look up 0.05, I think if I remember right, that's like 2.33.
1.645.
Oh, sorry. 1.645?
Yeah. Wait, 0.05? Yeah.
Yeah. So 1.655? 45? It has to be greater than this. Is this greater than that?
Yeah.
Significantly greater. So now what can we do?
Okay.
Reject the null. Accept the alternative. Yeah, man, we really have been skipping a lot of the extra work because they give you the standard deviation a lot, and but
Yeah,
I guess they wanted
a whole page.
I think they wanted to make you do it again at some point. I was wondering when they were gonna make you do it again, but remember, this is all from 107. So I'll post that
Have you guys
tonight.
taken 107? 7?